So now that Paul and Jay have gone Tryhard mode with their SLI 3090 configs, it's time for us to put something together. And for our next venture into RIPJAY and RIPPAUL, we need to go really, really big this time and use some of these on the 3090s. Before that, this video is brought to you by Squarespace. Squarespace is what we've been using for years to manage our own Gamers Nexus store, and we've been incredibly happy with the choice. Squarespace makes e-commerce easy for those interested in starting stores, but it also has powerful tools to build all types of websites. Photo galleries for photographers, resume and portfolio sites, and small business sites are all easily done through Squarespace. Having built a lot of client websites the old way before running GN full-time, we can easily recommend Squarespace as a powerful, fast solution. Go to squarespace.com/gamersnexus to get 10% off your first purchase with Squarespace. So as a reminder, if you haven't seen the previous RIP series challenges we've done, the whole point of it originally was Jay and I wanted to push ourselves and do things that were out of our comfort zone with working with hardware and with overclocking. So last time we did this challenge, I learned about chilled water, dry ice, and eventually got into liquid nitrogen overclocking. And Jay took a similar path using some different methods. He went more for dry ice, and we didn't try that until much later, but we each took different paths to achieve competitive scores. This time, because we've already done the chilled water stuff, I decided I wanted to try and improve by learning how to hard mod a card. And so one of the better ways to do that initially is to just solder some shunt resistors on top of the other shunt resistors. I learned this from Hi Cookie in Taiwan recently, and now it's time to apply that knowledge and try and do it without the oversight of a pro overclocker. One of the other things I'd like to try and do hard mods for this time would be potentially a volt mod or something similar to that. So this is going to be a good learning exercise. Jay has been considering doing some mods as well. So this is kind of the path we're going to take this time, since we've already exhausted a lot of the chilled water and exotic cooling solutions. And VBIOS is an easy way to get more power, but shunt resistor mods are just more accessible to everybody because you don't need access to a special VBIOS. So plan today, a couple things. We're going to do a shunt mod on the 3090s, on the FTW3s. I actually, behind the scenes, I already did this once on this card, and then we had an issue where it was not booting, and I was worried it was because of that, but it wasn't. It was because of an entirely unrelated issue, which is now resolved. But that ate about 6 to 8 hours or so of troubleshooting, but the card works. And so we're gonna shunt mod it again, except this time on camera. I need to do this twice. I'll show you how you check which shunts you would short. I'm not like a pro at this, and my soldering works terrible, but I know which shunts to short. And we've actually also shorted the fuses, which you should not do, because the fuses are there for a specific reason, but we did it to get around another unrelated issue that I'm not going to go into today. So we're going to piggyback shunt resistors on top of these 5. We will be using 8 milliohm shunt resistors, as opposed to previously we've used 5 for some mods. We've used 3. But the problem is if you change the resistance too much, so if you go down to like 5 or 3, then what you're going to do is reduce the effective power target that's visible or that's reported to you. So like take GPU-Z for example. If you run 5 and 5 piggyback shunt resistors, you might end up with, let's just pull some numbers out of the air here, maybe 75% power target as read by GPU-Z. Whereas natively you would see 100% power target. If you do 5 and 8, you might see something like 80% power target or 85% power target, or whatever the case may be, dependent on the baseline power that you're multiplying against. So our plan is to do 5 and 8. That's going to be a bit safer than 5 and 5, just from the perspective of not creating a scenario where it gets stuck into 2D clocks. We can always reverse the mod, but ideally we get it right the second time. So 5 and 8 should bypass any issues where the GPU will go into a safety mode if you tamper with the power too much, and you'll not be able to boost above with 350 megahertz or something like that. So it's very obvious when it doesn't work, and then you reverse it at that point. So that's our plan today. Some soldering, and then new cooler assembly. Okay, so first I'm going to show you how we check which shunts are going where. We've shown this several times. We show this in most of our teardowns at one point or another anyway. And it's pretty simple. We're just going to do you can do resistance and then check one leg of the shunt and then check one of the 12 volt lines. And if you don't know which ones are 12 volts, just look up PCIe pinout. We also have them conveniently on our mod mats on store.gamersnexus.net if you would like to look there instead. So for example, we can take this shunt down here, and these have obviously, I've worked on them already, that's why they're a mess. I'm not good at soldering. Let me make that extremely 100% clear. I don't do this very much. Just done a couple shunt mods in the past, unlike the Titan RTXs. So check one leg there, and then I think this one probably goes up to this power connector. So we're gonna hit the 12 volt. And if you look at the multimeter to my right, you'll see that these are connected. So that shunt will go to that one. We're gonna short, the only thing I'm checking right now is to make sure I'm not shorting any shunts that go to the PCIe slot. So if you short one that goes to the PCIe slot, that's not a good idea. The slot can't really take that much power to begin with. These cards are kind of borderline to overdrawing already. Oh, there it is. Okay, so this one down here, Jay, if you're watching, here's how you do this mod. I think Jay might have an unlocked VBIOS, which we've done in the past too. It's definitely easier, but I haven't gotten that, and I think this would be fun. So this one is going to the middle power connector. So I'm going to use a board preheater. I've got a fan. We talked about all this stuff in our side channel video. I've got a fan just to pull fumes away. And we're going to shove a thermocouple in here. That's going to give us board temperature. And then we're going to set the board heater based on that. That was quick. Can't tell if those are bound.
What does the flux do?
My understanding is that flux helps the joints bind. I don't know if it heats it up or what, but it helps it bind together. Lewis Rossman's got a really good short video on it. Like I was having trouble heating that up a second ago and melting it, and now it's working a little better, so I think that's partly why. Not really sure. I don't know what I'm doing. Ah! Okay, so we're done doing the shunt resistor mods. They're all piggybacked on there now. I did a quick test with just a liquid nitrogen pod on it, using liquid nitrogen, not for the competition, just for seeing if the mod worked, and it does get the power limit as we expect. So we're seeing like 60 to 80% range of power utilization instead of 100% previously, which means we've expanded the amount of power that the card can take significantly, and that's without getting a VBIOS profile or a VBIOS to flash onto it. I think Jay might have one of those, like a fully unlocked VBIOS. We don't, but the end result is about the same with the shunt resistor mod. And it's technically something you can reverse. Obviously, VBIOS is always a lot easier. So if you can find one, then awesome. But if not, you could go the same route we just did and do a shunt resistor mod. So we're gonna be adding water blocks now. This time we reached out to Optimus. I actually haven't worked with Optimus blocks before. So Optimus makes everything in Chicago. And this is the first time we're working with them. These blocks are basically prototypes. We got some of the first samples that they've made for the FTW3. They were really wanted to make sure we said that the way they were shipped and packaged is not how you all would have to work with them if you got one of the Optimus blocks. So, for example, because I was pushing them on timelines a bit, they said where they would normally laser cut a sheet of thermal pad to make it easy for a user to install or have it pre-installed on the block, what they shipped us instead was a big thermal pad that I will have to cut and install on the block. So I'm looking forward to that half hour, but you won't have to do that from what I understand if you buy it once it's actually a finished product. So we got early samples in. They look pretty good. So here's the blocks. It's a massive piece of acrylic. Optimus was keen to tell us that this should not be easily cracked by even hand tools, although we would need to see it subjected to the Joe Stepanzi bearded hardware test to really know if that's true for every human, or actually I don't know if he's a human, so maybe it is true for every human, but not whatever he is. The water block so the microfins on this are very densely populated, and a lot of open loop coolers, you'll see larger microfins that are more spaced. The closed loop solution, actually we have one back here, it's kind of nasty and like oxidized, but it still gets the point across. So this is from a closed loop liquid cooler. Typically the approach they take for these is skiving, and we have shots of like, if you look up our how a water cooler is made factory tour video, where we visited Deep Cool and Cooler Master, you'll see it. But typically closed loop stuff's made with skiving, where a machine pushes the metal and bends it straight, and it does that for every single one of these. It takes forever. They can only make normally a couple of these cold plates per hour per machine, which is a large part of the cost of closed loop cooling solutions. This is not made with skiving from what I understand, but it's denser, and the space between the bottom of the block, so the actual contact patch, the cold plate, and the microfins should be reduced versus some of the other manufacturing methods, like what we saw at Bits Power when we did a factory tour there, where you end up with a thicker cold plate and more distance to travel to get to where the actual microfins are, and that increased distance is suboptimal. You always want to get to your ultimate cooling solution as fast as possible with as few interfaces, as little distance as possible. So this should be really high performing. Our understanding is that this is still a prototype, but they've done some initial testing and they were happy with the results. The reason this works the way it does is because the whole backplate is used to tension the whole block onto the cart. So rather than just having the screws where the GPU is, we should get pretty even tension across the whole thing. What I'm going to do is actually, when I mount it, I'm going to take a torque driver, check the torque at whatever screw I'm happy with for the mounting pressure, and then I'll apply that same torque across all of them so that we can make sure we get even mounting. But you could also check by just making sure that PCB is not bending at all, because to quote Kingpin, if it's a PCB bending like a banana, then there's probably a mounting problem. This backplate will end up with a huge thermal pad on it. Let me find that. So here's the thermal pad. This is I think 3 millimeter thick Fuji poly pad. And I'm gonna try and break it free without cutting the pad itself. Okay. So our instructions from Optimus, when they said, hey, this is a prototype, but here's how to do it. Our instructions for them were to literally just cover the whole back plate. So easy enough. What I'm gonna do is cut it to size. We'll cut this end off since it bleeds over there. I guess I'll shift it to, we'll probably shift it to this part of the card maybe to cover more of the, actually let's look at this. Okay, so there's a little bit of an indent here. That would be for where the LED previously was on the EVGA card, but I intentionally removed one and then I accidentally melted the other one with the board heater. So it is no longer with us. But that's where that would go if it didn't melt. And so what I'm gonna do is take the excess thermal pad and shove it up here and probably down here, and that'll be where the inductors and the MOSFETs are. So not that it'll at that point do a whole lot, but a little bit of extra contact between the PCB and the back plate where the VRM is will do us the most good out of all the options. So as a reminder, here's what the card looks like on the back. We've got memory modules and the back of the GPU socket. In our teardowns, we always advocate for more thermal pads on the back. Some of the cheaper cards, you'll see a back plate, sometimes even a plastic one, like the old Gigabyte stuff, that literally does nothing and can even trap heat if there's nothing to transfer it. So in this instance, the back plate is being used to sink heat, and then we'll have fans on it to actively dissipate. So that will get the maximum usage out of it. We're going to make sure there's contact for the memory and for most of the VR app. What I'm going to do is just apply pressure. We'll cut out the holes where the standoffs are for the screws. So these holes, we're going to drive longer screws through into the plate, and then these will screw in through the PCB. So PCB sits on top of it like this. We'll have some hex screws that go through here to hold those, the PCB and the back plate together, and then the block will go, this isn't the correct orientation, but the block will go on top, and then the longer screws will hold that on. This thermal pad's ridiculous. 3mm thick Fuji poly pad is not cheap. I'm not sure what they pay, but I know what I would pay retail. And I think they're actually planning to ship this with the block too. So definitely the way to get the best use out of all your surface area, even if it isn't like finned, like a backplate often isn't, but also expensive. So let's line this up. I think the board, where was that dent? I've covered it. I think it was over on this side. So oh yes, if you haven't noticed, among the things I've learned in this RIPJAY challenge, talking about using it as an opportunity for us to each learn, soldering burns. One of the many things I've learned. We're going to remove all these thermal pads. These are the original EVGA ones. So I'm going to carefully peel these, and then there's hair on that one. And I'm going to scrub this thermal putty off of the inductors. Let's just cut this like right before that bend. And then the rest of this one will go over where the VRM is. Oh, that's just a through hole. Okay, so that's what we're going to do next is go through each of these on this side. Is that reflecting the camera? You see yourself. Go through each of these and make sure there's a path for the screw. All right, so we're going to grab a, what is this, a 1.5 from the GN toolkit, 1.5mm Allen. And I think some of this might be like pre-assembled, or it'll certainly have instructions and stuff for the retail model. But this is, I received a prototype, so this is how we're working with it. Just screws straight from the supplier. These are 1.5mm hex heads, assuming that's what they end up using in the retail model. I'm just going to get them all in place, and then we'll tighten them down more thoroughly after. Make sure they're all accounted for. I think there should be 5 or 6 for the back plate. Okay. Is it bending like a banana? No. It's pretty even. Okay, cool. So I'm just looking along here. Looks like we're good to go. Pretty even spacing, contact's good. So now I'm just going to remove these thermal pads, and then we'll do the pad installation on the block side. I'm going to clean off the blocks one more time if they need it, and that'll be it for setting up for water cooling. Okay, so got the cards done. We're picking up now a couple days later between all the other stuff we've been doing, and this is the start of the test bench for the actual RIPJAY benchmarking now that we've got the cards water blocked and everything. So this was, problem we had before was I was using a test bench next to a test bench, and the test bench was to use PCIe risers to separate the cards and get them the right spacing for NVIDIA's 4-slot SLI bridge. For whatever reason, NVIDIA in its infinite wisdom decided to do a 4-slot spacing for It's only first and only NVLink bridge. There'll be more later, but that's the first one that came out. And from what board partners tell us, they sell boards 9-to-1 for 3-slot spacing versus what this is, which is 4-slot spacing. We looked through our own inventory, and we have one board, other than the X299 stuff that we don't want to use, that has 4 slots. So anyway, we're doing risers, and in order to get some more stability this time versus what we did last time, what we used was Patrick went and pulled this panel out from a CaseLabs SM800, SMA8, whatever it's called, the massive CaseLabs case that we previously reviewed. So CaseLabs out of business these days, unfortunately, but this construct from them is still serving us today, and it's just the motherboard tray and the back panel from the case that can be pulled out separately. So we've done that, we've pulled it out. So we're using this to give some stability and rigidity to the cards. The problem I had with the previous setup was there was nothing really securing them. And now that we're adding water blocks that are as heavy as these are, I'm a little bit worried about things kind of moving around, or also just becoming more difficult to relocate things if I need to. So this bench will fix that. I have temporarily screwed in this dual pump. So I'd like to use D5 pumps because they should be a little bit better for this, but dual DDC is the best I have immediately available. And I just took a radiator screw and shoved it into the motherboard tray to support it enough to keep it in place anyway. And then this is masterfully secured to the table. So you won't see many people doing this, but that's because it's moving on. So we've got that running down to the huge radiator. This is a Mora 3 radiator, and the Mora 3 has served us through several of these RIP challenges before. We'll probably be putting it in an ice bucket soon enough. I want to start with just water and see if we can beat the scores that they've posted with only water, but we'll see. And let's see, I don't even know where I've got everything running. So that's coming out of the pump into the rad, and then the rad will spit it out to the video cards up here. We're going to do, this card will be first in the loop, this will be second, and then there's no CPU in this loop. We're sticking with an Arctic 360 CLC for the CPU, because that's good enough for now, and it'll reduce the amount of heat that's getting cooled by the same liquid cooler, which will make, it'll give me some extra headroom, reduce things a couple degrees potentially, and pull another 200 something watts out of this loop and put it in its own discrete loop. So that's the plan. I think I'll probably mount, I don't know, 200s, I guess, maybe 4 200s to the Mora 3. We could also do 9 140s, I think it is, but we'll probably go with 4 200s and see how that does. So let's get the cards. So here's the cards. This is, they've got a little bit of water in them, but still needs to be filled. My weakest point is going to be the QDCs. So these are quick disconnects. We have these to make the cards easily removable from the loop. Removing the CPU from the loop also means we're going to be dealing with fewer QDCs. These impede flow, and that's going to be our weak point. Now, for the fittings, we're using stuff that can accommodate these large diameter ZMT hoses. So these are, I think it's zero maintenance tubing is what it stands for. But these are ZMT tubes. We found these work the best for chilling things below ambient because they will take longer to build condensation, and also the wider internal diameter will help with flow, but bigger thing is just reducing condensation risk so that we don't have to insulate quite as much. So installing these won't be super fun. I had this on a board heater. That's why there's some condensation in there, because I was trying to heat up a couple droplets of water that ended up in the PCB. So I put that on the board heater to heat that out. So it's kind of still a little hot, but let's see, that's gonna go on the first slot. These are so heavy, these blocks. Okay. So the cardboard I have down is just in between the cables so that they're not like stabbing each other too hard, so that we don't have to worry about like piercing the underlying one with the weight and the spikes in the PCIe slot for the other one. So there's the card socketed. Just need to connect the tubes now and see if everything works. And I guess this will be, hopefully this will be as high performing as I think with these blocks and the capacitor, or the shunt mod rather, because I'd really like to not go to chilled right away. All right, so we had some water movement. Those are connected, and I'm gonna connect this to the radiator. So the coldest water will hit the GPUs right away, which will be useful if we go to chilled in a bit. Now let's see if they flood. They're not flooding, so we're good. Cool. Well, for all of you who have posted asking us to look at components made in the US, this is about the most America build you can get. We've got Optimus blocks from Chicago, and then the CaseLabs bench, what's left of CaseLabs anyway. So we'll see how the blocks do. They're not leaking, that's good. And now we're just gonna need to fill water, turn the pump on, run the pump for a bit, and hopefully, if everything is leak-free, we can just throw fans on the radiator and get going. I lost the cap for this somewhere, so this is how we're doing it. The tape is just to keep stuff from falling into it. Not to keep the water in, to be clear. Pretty sure that won't help. This needed power, so we're plugging power in. And now plug this in and turn power on. Is it not going? I guess I'll wait anyway. Okay, power test, see if the water goes. I might need to lower the pump. That's so annoying. Need to get the water above the pump. This loop always takes forever to fill with the massive radiator. I'm gonna probably have to put like a gallon of water in here. And as you can see, there's a lot of air bubbles in the loop. So I'm just trying to get it into the pump. I don't remember what the line in Lion King is, but I feel like I should say it. Keegan didn't boost Andrew's audio for that. It's not really working. Oh, there it goes. All right, sure. Why not? Finally got some water movement. Wow, that's some very rapid water movement. Nice. Just gotta saturate the loop fully. Did something just fall in there? No, don't go through. The hell is that? That was in there? Ew, I don't know what that is. What the hell is that? There's an alien growing in our water. Is there more of that shit in there, or is that it? I think that was it. So there's still a lot of air bubbles in the loop, as you can see in the blocks, but that'll work out, and we'll kind of let it run and see if there are any leaks develop or anything like that, but in the very least, that'll get it started and then kind of refill if we need to. I'm gonna get a proper cap for that thing though. We'll steal it off of another one. So loop order is, we'll just start here. So this block, water comes in from the radiator, the bottom of it, comes out here, goes in there, comes out here, and then that'll go into the, it's a little murky at the top, but whatever. It's not gonna be built that long. Comes into the reservoir, and then out here into the pump, out of the pump, back into the top of the radiator. Tubes are super long, so it is definitely a lot of work for the pump to do, but I wanted them to be long enough that we could get it into a tank filled with ice water later. So that's the main problem we run into. Could add a third pump to the loop, but the flow does look okay right now. We just need the air bubbles to work out. And this actually, the water level on this side of the block has risen quite a bit since I looked at it a second ago. So it's slowly starting to sort itself out. The acrylic on these terminals is absolutely insane. This Optimus acrylic, they were telling me on the phone, they're like, yeah, you're not gonna be able to break that acrylic if you try. I mean, they're right. I torqued the hell out of these fittings, and the acrylic is huge, and the waterways inside are huge. There's a lot of flow in this setup. I hope that's enough to deal with the heat load we're gonna be dealing with, but we'll find out. All right, so that's gonna be the end of the benching for this one. We'll show a shot of the system and the score, but I'm really impressed with the scores that system put up. So I spent probably about 6 hours or so doing some final tuning on, well, I guess I won't reveal that yet because then Jay will copy it. But I did some final tuning and spent a good amount of time on it. Ran only water, no chilling, no cardboard chute hooked up to an air conditioner into the front of the radiator. The end score, 29,242 points. That puts Jay within about 500 to 600 points or so of where we are as of today. And he's running, if you look at his 3D Mark score, at 17 degrees Celsius. So we were running at 25C for that. That is with the room ambient temperature dropped down to 18C. So that's total room temperature, 18 degrees Celsius. And now that it's getting colder outside, that's much easier to achieve at night. So that helped a bit. But the Optimus blocks, I'm very impressed. I've never worked with Optimus before. And the delta is consistently under 10 degrees above ambient, which is actually kind of crazy. So, and that's overclocked. So really good blocks. One of the other tricks I had to use was waiting for the entire system to cool down, not just the GPUs, but just leaving the system alone for 2 hours between runs gained me like 200 points. It was ridiculous. So I talked to Joe from Bearded Hardware, and his theory, that's all that this is right now, but both of us kind of think there's some kind of heat soak going on in the GPUs, where even though technically the exposed GPU sensor that we see for temperature is cooled down back to like a steady state idle, it's still behaving as if there's some amount of thermal strain on it. So we were thinking maybe it's in the memory, maybe there's some soak going on where you just start to lose stability over time after multiple runs as the whole board heats up, obviously, not just the GPU and the memory. So anyway, leaving it alone for about 2 hours and then firing off another run moved us from 29,000 dead to 29,242. And at this point, I've done, I think, absolutely everything I can do to catch Jay's score. We've passed Paul, we've passed BPS Customs, who has joined the battle. Welcome, Brian. And now it's just Jay ahead of us, and to get there, we need ice. The good news is, with the scores that we're posting now without ice, or without dropping the AC to 10, 15 degrees or so, we have better efficiency than Jay does. So once we move to the same cooling solution he's on, we should be able to beat his score pretty easily, but he's obviously gonna escalate as well. So that'll be fun. Started looking into doing volt mods on the card. It's gonna take some dexterity that I'm not sure I have with a soldering iron yet. But I am now, I spoke with a couple people, and my appreciation to those who shared their knowledge with me, and hopefully we could do it, but I'm not really sure I have the skills yet. So we might try that, but that's where you get into the territory where you could kill a card if you do it wrong. So anyway, 29,242, that's officially RIPPAUL. Paul was on ice, I think, and we're on just water. So Paul, back to you, and in the meantime, we'll start working on Jay's score next. We'll probably do a stream of it, and make sure you check back to catch that stream. Thanks for watching. A lot of fun as always, learning a lot, working on this. The volt mods, I don't know if I'll do them, but I've learned a ton about how they work in general, and it's really expanding my personal knowledge for working on video cards. So my hope is that we can sort of apply this going forward to reviews and things where it'll really influence our main content just by learning through this competition. So that's always the point of these competitions. They're fun, and it's a great learning opportunity to push ourselves more. So that's it for this one. Thanks for watching. Subscribe for more as always. You can go to store.gamersnexus.net or patreon.com/gamersnexus to help us out directly, and we'll see you all next time.